So we've done our probability distributions for discrete random values, and then we drew the histogram. So now we're going to do the mean of a discrete random variable. So you can see the formula is written right here. So remember mu of x, or the mean of x, is the sum of every x value times that value's probability, where x is the value of the random variable and p of x is the probability of observing the value of x. So this is the value, that's its probability. So they're asking us to compute the mean of this probability. So the first thing you're going to do is 1 times 0.32, which is obviously 0.32. 2 times 0.51, so I'm just going to do that in my calculator. 2 times 0.51 is 1.02. Now remember, we're calculating mean here, so it doesn't matter that it's going to go over times 0.12 is 0.36, and 4 times 0.05 is 0.2. And then we sum them. So I just add all of those together. So 0.32 plus 1.02 plus 0.36 plus 0.20 is 1.9. So if we read this in terms of the problem itself, this problem is the mean of the probability distribution, which represents the number of TVs in a household. So they did a study. They went to each house, and 32% of the time, those people had one television. 51% they had 2, 12% they had 3, and 5% had 4. So the mean probability, or the mean number of televisions that they would have, is 1.9. So that's what all of that means, if that makes sense. All right, so now let's do number 2, find the mean of the probability distribution, which represents the number of heads when 2 coins are tossed. So again, the same problem we've been doing this whole time. 0 heads, 1 head, or 2 heads. That's 25%, 50%, or 25%. The 0 times 25 is 0. 1 times 0.50 is 0.50, and 2 times 0.25 is 0.50. And if you sum those, you get 1.0. So that's the mean probability. All right, so the interpretation of the mean of a discrete random variable. Suppose that an experiment is repeated n independent times, so any number of times, and the value of the random variable x is recorded. As the number of repetitions of the experiment increases, the mean value of the n trials will approach mu, the mean of the random variable x, in other words. Let x1 be the value of the random variable x after the first experiment, then x2 be the value of the random variable x after the second, and so on and so forth. So then x bar, so this, remember, x bar is mean of a sample, is going to be the first experiment plus the second experiment plus the third, and so on and so forth, and so on, divided by the number of times you conducted the experiment. Now, the difference between x bar and mu gets closer to 0 as n increases. So what they're saying is, this is the mean probability distribution, theoretically, of flipping a coin 2 times. But if we experimented and we actually did the experiment, let's say I flip a coin 2 times, and the first time none of them are heads. So I'm going to write down 0. I do the experiment again, and the second time none of them are heads. I'd write down another 0. I do the experiment a third time, and this time one of them is heads. So it would be 0, 0, 1. Then I do the experiment again, and then again only one of them is a head. So it would be 0, 0, 1, 1. And so on and so forth. And then I would divide. So let's say at this point it's 0, 0, 1, 1 divided by 4, because I've done the experiment 4 times. So if I did that, at that point, I would be at 0.5. Well, my mu of x is 1. My x bar would be 0.5. But what this is saying is, the more I repeat the experiment, so I'm going to do more. I did 0, 0, 1, 1. I'm going to flip 2 coins again, and then flip 2 coins again. The more I do the experiment, the closer and closer and closer this x bar value is going to get to this mu value, the theoretical value. So I hope that makes sense. All right, so the next thing is expected value. Well, expected value equals the mean, because the mean of the random variable represents what we would expect to happen in the long run. The more that we repeat the experiment, the closer and closer and closer it's going to get to that mean. So we also call that the expected value, or E of x, of the random variable. So a car insurance company has determined the probability for various claim amounts for drivers aged 16 to 21. Calculate the expected value. So claim amount of 0, there's a 70% probability that they're going to claim nothing. And so you multiply 0.7 times 0, and that is 0. Multiply 2,000 times 0.15. There's a 15% possibility they're going to claim 2,000. That gives you 300. 4,000 times 0.08. So we've got an 8% chance they're going to claim $4,000. A 5% chance they're going to claim $6,000. A 1% chance they're going to claim $8,000. And a 1% chance they're going to claim $10,000. So once I sum those, that gives me my mean, but it also gives me my expected values. So 300 plus 320 plus 300 plus 80. I get 1,100. So my expected value in this case is $1,100. So they can expect claims in the amount of $1,100. How much should the company charge as a premium so that the company makes $50 per policy? Well, if they're going to expect $1,100 as their claim amount, how much should they charge so that they make $50 per policy? They're going to pay out $1,100, so they should charge $1,150. All right, a term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics Report, blah, 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 the probability that the female will survive the year is 0.99791. So it says it compute the expected value of the policy in the insurance for the insurance company. All right, so the probability that a person survives is 0.99791, and the probability, so that means the probability that they don't survive is 1 minus that, 0.99791. So that's 0.00209. All right, if they don't survive, then that's the payout. So that's $250,000 minus the $530 that they paid for it, because $530 of it actually belongs to the person. The probability that they survive is negative 530. All right, so negative 530 times 0.99791 gives me, I wish there was more room over here, but there's not, so I'm going to come down here. Yeah, actually, I'm going to come over here. is negative 528.8923. If they survive, so it's going to be $250,000 minus the $530 that they paid for their premium. So the amount of money that they would actually they don't get it because they're dead, but the amount of money that their family gets would be $249,470. But the probability that they're going to get that amount is 0.00209 times. So 521.3923. I need to sum those two values. 521.3923 plus negative 528.8923. My expected value comes out to be negative $7.40.